Okay, let's do the Laplace transform of a piecewise defined function. So I've got y equals this piecewise defined function. It's at 1 up until 3. And then at 3, it jumps up to 2. So even later when we learn how to find Laplace transforms from tables, a table is really not going to help me with this. There are ways to do this from a table using Heaviside functions, but it's more difficult than just doing the integral. We're going to use the definition here. So by definition, the Laplace transform of some function y is the integral from 0 to infinity, e to the negative st, y of t, whatever that is, dt. So I've got this piecewise defined function here. I'm going to have to write this as two separate integrals. I'm going to have one piece from 0 to 3 and then another from 3 onward. So this will be the integral from 0 to 3 of the first guy times 1 dt plus, and then the integral from 3 to infinity, e to the negative st times 2 dt. Now, we cannot just use previous results to do either of these. We can't say, oh, look, that's the Laplace transform of 1. It's not. The Laplace transform of 1 went from 0 to infinity. So we have to actually do the integrals here. This is where mistakes happen. You have to actually just do the integrals. Okay, and I'm going to get kind of hand wavy here, not worry about that limit as b goes to infinity stuff. I'm going to write out like my limit of integration as infinity, and we know how to deal with that. Remember, however, these are all t equals. My limits are t's. And this is technically t goes to infinity. It says t goes to infinity. All right, let's just do the integrals. Antiderivative of e to the negative st would be excuse me, negative 1 over s e to the negative st, evaluated from 0 to 3, plus, we get nearly the same antiderivative here, but now we've got a 2, so we'll get negative 2 over s, evaluated from 3 to infinity. And remember, we know that really means the limit is, oh, I forgot my e to the negative st. E to the negative st, evaluated from t equals 3 to t approaches infinity. Okay, so let's write all these out. So I'm going to pull out this negative 1 over s here. I'm going to have top minus bottom, e to the negative 3s. Remember, we're plugging in for t, not for s. Minus e to the 0 was 1. Plus negative 2 over s. Plugging in t equals infinity, we'll get, I'm going to write this down, but then I'm going to erase it. E to the negative infinity. Well, that's really a limit as t approaches infinity. And we really have something like this. We've got an exponential over a polynomial. Exponentials dominate polynomials. The exponential is going to win. This first term is going to go to 0. Minus, and then plug in the bottom, e to the negative 3t. At 3s. I have a habit of wanting to do that. We're plugging in t equals 3. Okay, and now we can just clean up. So let's see, that term's going to be 0. I'm going to have a 1 over s minus 2 more. But no, when I distribute there, I'm going to get a plus. I'll just write all these out. Negative 1 over s e to the negative 3s plus 1 over s plus 2e to the negative 3s over s. So those two will combine together. Those are like terms. So I think we just get e to the negative 3s over s plus 1 over s. And there's our final answer.